Welcome to this tutorial about the base principles of AutomationML. In this tutorial, I want to demonstrate how to model AutomationML libraries as the basis for the development of standardized digital data models. Let's switch to the AutomationML Editor. Before we start modeling, I assume that you have a certain application case in mind. For instance, you want to store your data in a standardized way. Or you have a business case in mind to establish a digital data exchange between two tools. In both cases, it's useful to first agree on the general content of the data model and second, to design the model in form of an ML library. In the next minutes, I will show you the main ingredients for AutomationML modeling. First, AutomationML supports 5 types of libraries. Let's start with the AutomationML attribute type library. First, start the AutomationML Editor and then create a new attribute type library. Technically, you can name the library as you want. The AutomationML Association, however, recommends that the name of the library should be meaningful. First, identify the creator of the library. This might be an organization, a name, or any string you believe is meaningful. In this case, I name it demo. Then we add an underscore as in separator. The next part of the name is the domain. In my example, I name it base units. The next part of the name is the type of the library, in this case attribute type lib. Now we have a meaningful library name according to the library naming conventions. Now let's model an attribute type. I add the attribute private length. You can repeat this procedure to all your attribute types you need. And the next step, I model a second library, the AutomationML interface class library. Here I define an interface type USB and Ethernet. Now I model a third library, the AutomationML role class library. Here I model the role class robot, PLC, computer, printer, USB cable and Ethernet cable. Now we can start modeling an AutomationML system unit class library. In this library, we model the core of the digital data models, all the elements we need to model your domain. In my case, I create a system unit class ERB14000, an AC500, and Lenovo 123, and HP DeskJet 100, and USB-C cable 001, and a Cat7 easy line. Each of these classes represent a certain type of object. To further describe the content of those classes, we refine it. I add a length to the cable. I add an USB and 2 Ethernet interfaces to the computer. I add 2 Ethernet interfaces to the PLC. I add 1 interface to the robot. And to semantically identify what a robot, a PLC, a computer and a USB cable or an Ethernet cable is, I attach the corresponding role classes to the related system unit classes. These are the main principles of modeling AML libraries. After developing and finalizing such a digital library, you can share it with your partners like you would share an Excel template. And then, based on such a digital library, you can establish digital data exchange. The next question is how to use such a library. I give an example by modeling a technical system manually. In reality, nobody models a technical system manually. What I do now is later done by software, but for educational purposes it is useful to see what's happening. For any type of system, I create an instance hierarchy. In this case, I name it my project. In this hierarchy, I create an internal element, my lab. Within this object, I add an instance of the robot, the PLC, the computer, the printer, an USB cable and an Ethernet cable. Now I connect the computer with the robot via Ethernet, the computer with the printer via USB, the computer with the PLC via Ethernet, the PLC with the robot via Ethernet. Remember, in reality, those models are created by software. They represent a technical system that is already defined in the source tool. After export, the model is compliant to the AML library and can be stored or submit it to any target tool. And as long as the target tool knows the underlying ML library, it can automatically understand the system. And if there is an unknown class which the receiver does not know, it however knows exactly which class it does not know and can take action to fix that. What do we have achieved? In this tutorial we have modeled my demo plant. But in real applications you should model your domain. AutomationML is a language, it's not an out-of-the-box solution. The data exchange with AutomationML requires AML libraries that are specific for certain use cases. Organizations are invited to develop their own building blocks to depict their own domain. And therefore AutomationML is domain independent. It can be used for modeling P&I diagrams, manufacturing plans, process plans, subsea systems, space systems, family trees, hospital organigrams. It is multi-purpose. And therefore you are invited to model your world with AutomationML in the way you need it. And the best is to standardize those libraries as a domain library in your domain.